Hi, everyone. Welcome back. So this is day 2 of the Open Web Foundry. Today, we're going to talk about all of the different tools that you can use to build decentralized, immutable, permanent web applications. So I'm going to share a quick deck, and then I think we'll be going to GatherTown afterwards, which is now publicly available, so anyone can just jump in the link. And we'll chat there and go through any questions anyone has. There's also a sort of well, I think you guys should join and you can check it out for yourself. It's a great place for you to chat to one another, and then there's also sort of an auditorium room where we can have like larger discussions, almost seminars there. So I'll share a quick deck, and then we'll get to it. Thanks, India. That's perfect. Okay, great. All right. So the game here is to build fully decentralized web applications, and we don't just mean decentralized in the sense of Ethereum. Apps being decentralized, or what we typically, at least maybe in the last few years, called dApps. We mean literally top to bottom of the stack, every single thing is decentralized and redundant. So you can access the application from anywhere. In fact, if we were to be more concrete about it, I think we'd say that the goal is to create applications that are governed by code, that are always accessible, and that run forever. And we went through the reasons that we think that's exciting yesterday. But I think the general principle is that we have, code is law, but for web applications, and then have those web applications accessible all across the world by a multitude of different gateways, so they are truly decentralized. And one of the sort of, great archetypes of this is actually Verto, which itself is a profit-sharing token exchange, but it uses almost every technique that we outline here. In fact, I think actually the one thing it's not using is decentralization of the UI, but we'll get to that first. Everything else is literally completely decentralized in this application, and the UI could be trivially decentralized. I just think they haven't gotten around to it yet. Another good example could be something like weve.email, or weavemail, we call it, a mechanism through which you can send mail to other people on the PermaWeb. That application is completely decentralized top to bottom. There is no way that any of us can revoke access to it, and it's the way that application simply works is simply governed by code. The code that is stored on the network is the code that everyone runs, and that is the way that we see the application when we view it in our browsers. So, on top of the Arweave base layer protocol, which really just does permanent information storage backed by endowments, as we discussed yesterday, and also this sort of scalable mechanism of data storage. There's this stack of protocols that we call the PermaWeb. And that's really what we're going to explore today, like how all of this stuff glues together to make it so that you can build these fully decentralized applications. But it's not just Arweave, you could say. It's a whole bunch of stuff built on top of it. A lot of it mostly by our community members. I'm sure many of whom are in the chat. So, okay, to get into it, the first thing that we need to understand is like what technologies will we need to know in order to build applications. Fortunately, this is basically all generic web stuff. If you know HTML, CSS, JavaScript, or TypeScript, and GraphQL, and that last one, I think you can learn pretty quickly if you're not already aware of it, then you can build fully decentralized web applications on the system that I'm about to describe. There's not really much more to it than that. The HTML and CSS stuff, if you're more comfortable using frameworks, generally those frameworks also work within the system. You just have to compile them down until they get to their HTML, JavaScript, CSS form, so that you can use less, for example. And on the JavaScript side, you can, of course, use like React.js, this type of thing, and have that be deployed to the PermaWeb and fully decentralized, just like everything else. Your normal tools and frameworks generally work on the PermaWeb just like they do on the centralized web. Sometimes with very small modifications, but if you were to take away anything from this, it's that if you have questions, you should just go to the developer Discord for Arweave and just ask, because almost certainly someone's had the same question before and we'll be able to answer it very quickly. There's a huge amount of body of knowledge of how to build these things available in the community that you can find there. So I would really recommend you do that. But generally, this is the idea. Okay, so the languages, we're using normal web languages, but we're using slightly different tools to deploy them generally. So we'll go through now in turn what it is that you would actually use to put the, for example, to put your UI onto Arweave. So you've got a UI which is going to be talking to either a smart contract or a backend or database, which itself is actually just Arweave, but through GraphQL. So you've got this UI that's doing these actions to generate the experience for the user. How do you put it on Arweave? Well, the best way generally nowadays is a community-built project called Argo, which is a deployment system. You can go to their website, you can add a GitHub hook, you press a button, and then when you deploy, when you push or when you press the button, depending, then your site is just pushed onto the PermaWeb, and you pay them a very small amount for the fee of doing, or for the privilege of doing so. And it's actually a profit-sharing community that you can buy into if you want as well. And just as we were discussing yesterday, they're using a what you could call usage mining system. So when you use the system, you actually earn some Argo tokens as well. So you earn ownership of the platform that you're using. It's a very nice UI, which you can show here. It's almost looks like GitHub actually. It's very elegant, very simple to use. And it can easily attach your PermaWeb application to a domain name, which is quite important because that's a tricky step that you can't really fully decentralize, unfortunately, because DNS just ultimately is not decentralized. Another system that you could use to deploy your UI is made by another community member, also the founder of community.xyz, which is Arweave. Or there's some disagreement about how this is supposed to be said. ARKB or Arweave or whatever you want. It's all the same thing. It's a simple command line deployment tool. You build your application. You say, hey, here's my key. Here's my directory. Go deploy it to the PermaWeb for me. And it says, sure. And then it gives you back a TX ID that you can use to refer to your application. So then you can just put arweave.net or any other gateway, stroke TX ID, and boom, you get to your app. Arweave Deploy was the original deployment system. You can install it by just going in npm install Arweave. It's pretty easy. And then you can just say, Arweave deploy, Arweave space deploy space, and then your file or directory. So deploy _dir if you want to do that as well, but all the docs are online, of course. And it'll deploy your site for you either as a bundle. And so this will use sort of basic rules to try and just take your site as it is and bundle it into a single HTML, CSS, JavaScript, application, essentially, just in a single minified form, and deploy that to the PermaWeb. And then it gives you back this TX ID. But generally, people now are moving to use Arweave because the size of the projects are getting larger, or Argo if you have a really significant site that you want to deploy. I think it's like the top tier now, essentially. But Arweave probably faster to get started with. Deploy even simpler, maybe. So that's the kind of hierarchy. Like if you have something really serious, you might want to go with Argo. A little bit more serious or complex, Arweave. And if you just want to get started and playing with like deploying your hello world HTML file, Arweave deploy, npm install Arweave is what you probably want to go for. Okay. The next thing you want to look at when you're building your application is, so cool, you've got the UI hosted on Arweave. That's great. But how are you going to interact with it and make it dynamic, right? A decentralized web is not just going to be static files. You need to be able to write to a database, essentially, or something you can use like a database. And the way that you can do that is through Arweave.js and Arweave bundles. So Arweave.js is a very simple system. It looks like this when you use it. You can just include this JavaScript module or TypeScript module. And then you can take the library and you instantiate it in a very simple way. Hopefully the guys are dropping a link to this in the chat as we go. Ideally, we'll get links to all of this stuff so that you can kind of read about it and check the docs while I'm speaking through it. But it's very simple. You can just Arweave create transaction. You can sign the transaction with a key. And you can either use a JWK there, so a JSON web key, or a string that just says use wallet. And we'll get to the wallet infrastructure a little bit later. And then you can post the transaction to the network. And then it'll give you a response status and all the rest of it. It's fairly unsurprising, but very, very, very simple to get started with. If you've already tried building with Web3.js on Ethereum, congratulations, this is about 1/10 as complex. It's very, very simple to get started with. And similarly, if you want to make many, many database writes, you can do it with Arweave bundles. And that, you can look at the library, just search Arweave bundles on Google and you can find it, or someone will drop it in the chat here. yeah, the idea is that you can take many sub-transactions, which in this case we call data entries, and just bundle them up, as it says on the tin, and dispatch them to the network all at once. And that means that you can write, tens of thousands, hundreds of thousands, or more even, writes into the database, inverted commas, at any one time, without having the problems that you normally get with scaling of a blockchain. So that's the way that you should do this. If you're writing really large quantities of data, you just batch it up and dispatch it in one go. One of the key things to understand about Arweave is that you are able to use it like a database because everything has arbitrary tags associated with it. And you can put in that tags whatever data you like, and then you can search on those tags. So in a Twitter-like application, for example, you would say, hey, here is my post, and so that would go in the data body probably, and it's you could say, I don't know, a discussion about this. So you could say contains hashtag, so a hashtag might be one of your tags, and then you have the tag as the value, so it's just key and value storage. And then you can query the database, and you can say, and this is through GraphQL, you can say something like, hey, in this case, the tags we're looking for are any transactions that have been submitted to the network, any transactions or data entries, so bundled transactions, any data entries of any kind that have content type and then text HTML, or and user agent with this particular user agent. That's just one, but we could imagine that this would be like app name or protocol name, and then you could have the name of your Twitter-like system, and then also, I don't know, the hashtag or topic, something like that, and then you can have the values there. So GraphQL, if you haven't already seen it, is a little bit complex when you get started. Although frankly, I don't think it's as complex to learn as SQL or something like that if you're used to those systems. But it does take a little bit of getting used to. Fortunately, the lone Ronin, who's a pseudonymous founder from the network, who's building Amplify, which is a gateway network on top of Arweave, which exposes all of these interfaces, actually these database-like GraphQL interfaces in a decentralized and incentivized network. He made a fantastic guide, which hopefully someone will drop a link to in the chat now, which takes you through all of the basics here. And if you kind of follow that, you'll get to the point where you can make your first application very easily. And now your decentralized web application can be dynamic. So it can load the UI from the network itself, because you deployed with Argo or Arcbee or whatever it is. And then once you've loaded the UI, you've queried the network, perhaps for the latest tweets or posts or whatever it happens to be, and you get a response that you can then just read, using Arweave.js, and then you can render it on the screen in a very, very simple way. And then you have fully decentralized and dynamic web applications. And then, of course, you write back into the database using Arweave.js and Arweave bundles. So this is kind of like the full stack on that side of things. That allows you to basically do everything you need to do for decentralizing most Web 2 applications. You can take it a little bit further. So on top of this, of course, and one of the exciting things about the crypto space is it allows you to build smart contracts. And in Arweave, we do that through a system called SmartWeave. SmartWeave is itself a modular smart contracting protocol, you could say. Really what SmartWeave does is it's built completely on top of the Arweave base layer without any edits to the Arweave base layer. So it's completely a layer 2 solution. What it's really doing is saying, okay, when I want to get the state of a contract, what I do is I get the initial state, the contract source code, so the program text, and then I get every single interaction that's happened with that contract, or claimed interaction that's happened through GraphQL, actually, that we discussed earlier. And once it's got this ordered list of transactions, the user's computer just goes through and it says, okay, well, I will execute in turn. Yes, I will execute in turn each of these until I get to the current state of the contract. And if I find an interaction that's actually invalid, then I just throw it out and go to the next one. And what you're really doing is you're inheriting the total ordering, so the concrete deterministic total ordering of the transactions that are entries into the system from the Arweave base layer into your smart contract. and subsequent, or into the smart contracting realm, you could say, or into the really it's a protocol. It's a protocol built on top of Arweave. Yeah, and this allows you to do all kinds of fork avoidance type activities that you have to do typically inside the smart contracting system, actually at the base layer, and so they don't have to be expressed in the smart contracting system at all. So SmartWeave itself is just like 300 lines of code, or at least it was when it started. Now it has lots of extra nice features. But what's important to understand about this is that unlike other smart contracting systems, we're using you could say a model of lazy evaluation. So when a user writes an interaction into a SmartWeave contract, that interaction is not executed by the nodes in the network. And that means that the security model can be completely different. On Ethereum, when you write a transaction into the network, every single validator in the system will execute that code. And then in the future, every person that wants to validate the Ethereum blockchain executes every single interaction with every single program. This means that the programs that are being run must be very, very safe. So you can think of it as there's like a three-party system for the execution of smart contracts there. There's the user who invokes a program, which is written by a developer that runs on the machine of a validator. And so now the trust relationship is that the user trusts the developer and the validator has to run the code on behalf of the user, which obviously means that the code has to be really locked down. You can't really do very much. It can't do very complex computation because we don't know how long it'll take. Maybe it'll never terminate, that kind of thing. And also we can't do interactions with any potentially dangerous services at all. Really, it must be, and they all must be definitely deterministic. So you have to really pare down the things that programming environment, which is Solidity on Ethereum, can actually do. Whereas if you imagine the relationship that the user or the security model that exists inside operating systems, for example, you see it's actually very different. It says that the developer is trusted by the user, and so the user runs the code on their machine, and that's the end of it. And whatever that developer has put in the code is what's executed. Well, SmartWeave is much more like that, because the validators just aren't involved in the execution of code anymore. And this is really powerful because it means that we can loosen up a whole bunch of those constraints that you would previously have with smart contracting systems. So now you can run arbitrary amounts of compute for no extra cost because the compute's going to run on the user's machine. And the user has decided to trust the developer who's chosen how much compute to run. So that's up to them. If they want to run 2 hours of computation for a state transition, so for a single input to the smart contract, do it if you want to. That's okay. And also if they want to do potentially unsafe or dangerous things, or even potentially non-deterministic things, so things that might even result in different outcomes over time, or things that you potentially can't be sure will result in the same outcome. All of these things can be done inside SmartWeave contracts because the security model is just totally, totally different. So one way of thinking about this, and finally, you can write it in very simple programming languages. Like you can actually write these in JavaScript by default. Now, some people won't want to write their smart contracts in JavaScript because JavaScript is, I would say, a generally fairly unsafe language. And so subsequently, you can also write your smart contract in anything that can compile to JavaScript. And so, for example, there's a very simple library to do this with the Clarity language, which was developed by Blockstack and Algorand originally, as a very safe, very simple way of building smart contracts. If, simple asterisk, if you are familiar already with Lisp and Scheme. If you're not, then maybe you want to look for something else. Yes, but so you can write JavaScript smart contracts if you want. You can also write in higher level languages which compile to JavaScript. Somebody's even writing a system that allows you to compile Solidity contracts down into JavaScript and run them inside SmartWeave. It's really up to you. TypeScript obviously runs in this system, of course, and really anything else. There's a new programming language called Uwu. I hope I'm pronouncing that correctly, UWU, which is built by some of the team at Verto, who are building essentially this you could say a safe subset of JavaScript that you can run inside SmartWeave contracts very simply. And it's an elegant, nice, simple language. So you have a lot of freedom in this system. And it also allows you to do fairly complex things because it's using languages you already know very simply. So for example, here is the entire contract for a token. This is just an arbitrary token. You think of it like an ERC20 if you're from the Ethereum world, or just if you're not from the Ethereum world, think about like Ether or Bitcoin or something like that. Can be defined in just, what's this, like 35 lines of code. And most of that is just error checking. So making sure that the user has, given a target, for example, that target actually has enough tokens, blah, blah, blah. You get the idea. Yeah, it's all very simple relative to normal smart contract development. There's a lot more to be said there, but I think that's enough to dig into. Now, final advanced topic, I think, is back-end nodes. So if you're like, okay, this is cool, so I can do my front end, store that on Arweave. I can also do my database interactions, store those on Arweave. That's neat. What do I do if I want to do like back-end compute? Like I want to pre-compute the output of some long-lived process and then serve that to people every now and again, for example. Well, you can even do that in a decentralized way on top of Arweave, using a system we call community compute. This essentially works. It's more complex. That's certainly true. But you can still achieve it in a fairly simple manner relative to normal smart contract development. So the basic idea is this. You take your profit-sharing community, which exists on a platform called community.xyz. It's really just a SmartWeave contract, as we described. But there's a nice UI on community.xyz that you can go to in order to manage it, essentially, deploy and manage those contracts. Well, you can, in your community, and this is a profit-sharing community, as we described yesterday. This is the basic contract for it. In your community, you can vote to elect people to run nodes. Well, actually, you can vote to elect people to do anything. But one of those things can be to run a node for you. And the idea would be, it's really quite simple, actually, is that you have someone in your community that is kind of trusted, and they're staked in for a long period of time, and they might volunteer, or you might pay them in one way or another. So you send them a bit of a tip from the application. You might pay them to run the node for you, and so you get the smart contract state when you're executing the application, and that will say, oh, okay, you should go to this IP address, and that's the IP address of, or even actually a domain name might be safer, run by someone from the community who has a stake, and then the users of the users of the application, the community around it, if that person running that node, which can be written in whatever language you want, in whatever stack, your just normal back-end development system, if they stop doing that in a trustworthy way, you can discuss amongst yourselves, and you can either elect someone new or elect someone new to run the node, and also slash the stake of the person that was previously running it. So there's an economic security game here. If you, for example, ask me to run a piece of compute for you for like a month, and you say, okay, we'll I don't know, mint 1,000 tokens to pay you with, like $1,000, whatever, and it's going to cost me $200 to run the node, then I'm well incentivized to do so. And also my stake in the community might be $10,000. So now you have an economic security guarantee of $10,000 that if I stop running the right code, everyone can come together and kind of agree on this, and they can slash my stake, so I lose $10,000. So I'm very disincentivized from annoying the rest of the group by essentially maliciously running the code or not running the code as defined. But also afterwards, if I do it correctly, you can vote to reward me with some more ownership of the project, or maybe even just some tokens. So you can, use these kinds of DAO-controlled compute system. And so DAO is just a decentralized autonomous organization. We call them in the Arweave ecosystem communities, because that's largely what they are. But these community or DAO-controlled compute systems really just work by staking and slashing and electing people to run the node. It's quite simple in theory. It's not so complex in the code, but unfortunately, there aren't lots of examples that you can look at. One of them that you can, for example, is Verto.exchange. That uses community compute nodes that are staked into the DAO to allow you to run back-end, essentially matching engines for the exchange. And I'm sure the Verto team would be very happy to talk to you if you wanted to about how to set up a similar system in the network. So I think the key takeaway here is that there's a lot of different components realistically going on in this stack that is now the PermaWeb. It didn't start like this. It all sort of grew organically over time. There's things on the economic side, like profit-sharing communities, which are controlled by community XYZ, which we didn't even get into here really. But then on the technical side, deployment systems, there's many of them. Systems for deploying data to the network, also a few of those. Only one system for querying data from the network at the moment, at least. Although we have actually seen one project build their own custom gateway with its own indexing system, which used SQL. That was FeedWeave, all that code is open source if you're interested in spinning up something like that potentially. And then smart contracting systems where there's a lot of choice. I think that the ultimate upshot here is that there's a lot of choice with building these applications, and it's very, very possible to build fully decentralized web applications here in a way that I don't think, to my knowledge, you can build anywhere else. And this has really only just become possible over the last 3 or 4 months on Arweave even. So we're right at this sort of burgeoning edge of the ability to build these applications that truly live forever, are governed by code, and are permissionless. It's all extremely exciting, but that no doubt means that there's a lot to get your head into. It's a real rabbit hole. And so the thing that I would just stress again is, if you're confused by anything, if you think that something might be possible but you're not sure how, or even if you think something isn't possible, you want to check, just talk on the Arweave Dev Discord server. There's many people around that can answer your questions, help you get on board, and point you to resources from other people that had the same problem previously and solved it. Because there, at this point, frankly, are very few things that you might want to do while building a web application that you can't do in a fully decentralized way on top of the Arweave network. All right, so that's a map of the space, if you will. If you want to just get started, go to arweave.org. There's lots of docs there, but frankly, the ecosystem is so sprawling at this point that it might be best to have a guide. And so reach out to us at the Arweave core team, or people from the community, for example, Tate from Verto, or Phil, who goes by Villanarius, on the who's a founder of Arweave, on the Discord server. Really just people are there to help you. Reach out to them, and you will get the assistance you need in order to flourish here. All right, with that, I guess we should jump onto gather.town. Thanks everyone for coming.